In recent videos, we've seen how to determine the final amount in a bank account given the prior amount and the relevant interest information and number of years. And we've also seen how to determine the principal given the final amount and again the relevant compounding information as well as the number of years. Well, in this question, we're going to be given the final amount and the prior amount, but we're going to have to figure out what the interest rate was. And this is usually, most students feel, a more difficult question. Well, let's attack it. Belinda deposited $2,500 8 years ago. She made no further deposits or withdrawals, and today she has $3,369.14 in her account. The interest rate was compounded annually. We'd like to know what it was. Okay, well, we see that our final amount after all the interest occurred was $3,369.14. We see that the initial amount invested was $2,500, and we see that the end value should be 8 because we're compounding annually and we're doing it for 8 years. So we plug all this information into our formula. A equals P, 1 plus I to the n. That means 3,369.14 equals 2,500 times 1 plus I to the exponent 8. We can divide both sides by 2,500 and we get this formula, we get this amount approximately. 1.347656 equals 1 plus I to the exponent 8. Since we're looking for interest rate, we're trying to isolate the I. And I'm going to show you a little method we can do that goes back to the power rule we learned some time ago. If I raise this entire right side to the exponent 1/8, the power rule tells us that I multiply 8 times 1/8 to get a new exponent of 1. Well, what I do to the right-hand side, I must do to the left-hand side. So if I'm going to raise this entire right-hand side to the exponent 1/8, I should raise this entire left-hand side to the exponent 1/8. For ease of use with the calculator, we should figure out what 1/8 equals. 1/8 equals 0.125. So this is perhaps the most difficult step in this compounding interest section. What we then do is we raise the entire left-hand side to this exponent and the entire right-hand side to this same exponent. What we do to the left, we must do to the right. So I raise the left-hand side to the exponent 0.125, and I raise the right-hand side to the exponent 0.125. Well, using our power rule, we see that in this situation, we multiply exponents. 8 times 0.125 equals 1. So I'm able to say that the new exponent on the right-hand side is 1. Well, while I'm doing that, I should also figure out what does 1.347656 to the exponent 0.125 equal. Thankfully, I have a calculator to tell me. The calculator tells me that that amount equals 1.038000066. Well, I'm going to remove the exponent 1 from being visible here. So I'll call it 1 plus I. I'll round this down to 1.038. Now I almost have I isolated, but what I need to do is subtract 1 from the right-hand side and subtract 1 from the left-hand side. Doing that subtracting tells me 1.038 minus 1 equals 1 plus I minus 1, which tells me that 0.038 equals I. Going back to our table, we know that this was an annual compounding situation, which means little letter I was simply equal to the interest rate. Since we're going to express it as a percentage, we move the decimal place back over 2%, and we can say the annual interest rate is 3.8%. Well, a difficult question like that warrants one more example. So here it is. Suppose Christina deposited $1,700 4 years ago, and she never made any further deposits or withdrawals, and today she has $2,027.28. Well, Since interest was compounding annually, we now have enough information to figure out the interest rate. The amount after was $2,027.28. The amount prior was $1,700. Little letter I is essentially what we're looking for, and n equals 4 because this occurred 4 years ago and because the compounding occurred annually. So we plug the information into our formula. 2027.28 equals 1,700 times 1 plus I quantity to the exponent 4. Divide each side by 1,700, and what we get is 1.92517647 equaling 1 plus I to the exponent 4. Now you might be saying again, why so many decimal places? Because we wanted our final answer to the penny. We know that 1/4 equals 0.25. So we're going to raise this entire left-hand side to the exponent 0.25 and raise the entire right-hand side to the exponent 0.25. Why? Because what that does is sets up a power rule where 4 times 0.25 is 1, and we have 1 plus I to the exponent 1 on the right-hand side. We're making it simpler. Now this is a number that needs to be calculated by a calculator likely, and we get 1.044999791 equals 1 plus I to the exponent 1. Well, since we have a exponent of 1, we can simply express it as 1 plus I, and we can round this to 1.045. Well, we want to isolate the I, so we're going to subtract 1 from the right-hand side and subtract 1 from the left-hand side. 1.045 minus 1 equals 1 plus I minus 1, which means 0.045 equals little letter I. So the annual interest rate is 4.5%.